Hello everyone. I hope you are excited about today's topic, the distributive property. So we're going to continue here on with our Algebra 1 series. And we have two main goals today. One is to use the distributive property to evaluate expressions. And then second, we are going to use the distributive property to simplify expressions. And in my line of work, this is key, simplify, because we want to make things easy. We want to take complex stuff and make it real easy to do. So I'm really excited about simplifying expressions today, and I hope you are as well. All right, let's go ahead and dive in. All right, let's say that we have a video game store and they have some games for sale. And let's say we got some NASCAR games. We got NASCAR Heat 4, and this is for PS4. This is for sale for $15, okay? Because it's a little bit of an older game. Then we got a little bit newer game. NASCAR Heat 5 for PS4. And this is for sale for $30 because it's a little bit newer. Then we have NASCAR Ignition this is for PS5. But this is the latest game, so it's for sale for $40. Alright, so we have, first thing in the morning, 3 customers come in and they buy 2 games each. And they buy the same 2 games each. They buy NASCAR Heat 5 and they buy NASCAR Ignition. Okay, so let's write this out mathematically. We have 3 times $30 plus 3 times $40. Okay, we could rewrite this, and this is going to be using the distributive property. Okay, we're going to rewrite this, since this term here is common and this term here is common, we're going to rewrite this as 3 times $30 plus $40. Alright, so let's look at the distributive property and what does it mean mathematically? Okay, so it's the same as x times y plus z. This is equal to x times y and x times z. So x times y, and then we have a plus sign here, plus x times z. Okay? And we can rearrange this. We can say y plus z and put x on the other side. So then here we're going to multiply this times this and this times this. Whoop. And it does not like that. And remember, we have this plus sign here. Okay? So this is going to be equal to y times x plus z times x. Or as my British friends would say, z. So that was looking at multiplication and addition. You can also do this with multiplication and subtraction. So if we have x times y minus z instead of y plus z, this works out pretty much the same, except for, remember, we have this minus sign here. So x times y minus x times z. That's all it's really different. Okay? So over here we can rearrange everything, and this would be y times x minus z times x. Okay, let's look at an example of this with some numbers instead of letters. Let's say that we have 3 times 7 plus 12. And this is equal to 3 times 7 plus 3 times 12. Okay, now on this side over here on the left, we could just add together 7 plus 12. So we get 3 times 19. Okay, and we can go ahead and solve out this on the right hand side and this on the right hand side. So we go 3 times 7 is 21 plus 3 times 12 is 36. Alright, now let's continue to solve here. And 3 times 19 is 57, and we know 21 plus 36 is 57. So they work out to be the same. So that's an example with some numbers of the multiplication and addition using the distributive property. Let's look at another example, but with multiplication and subtraction. Alright, so we have 7 times 40 minus 12. Okay, we can rewrite this as 7 times 40. Remember, this is minus, so minus 7 times 12. Alright, so on the left-hand side, let's go ahead and solve what's in the parentheses. 7 times 28. And on the right-hand side, let's go ahead and solve this. 280 minus 84. Now, just looking at this, in my opinion, and this is strictly just my opinion, I would think it's a little bit simpler to solve the right-hand side versus the left-hand side. When I do the multiplication of 7 times 28, it gets a little mathy. But on the right-hand side, I know 280 minus 80 is 200, and minus another 4 is 196. So it's a little bit simpler for me to solve. So we'll go ahead and solve this since I already gave you the answer. 196 and 196. Alright, let's look at another example here. Alright, let's say we have 12 times 99. Okay, so using the distributive property, we can actually simplify this problem a little bit. 12 times 99, that's a little difficult to do. So what could we do here? Well, we know that the number 100 is real easy to work with, and the number 1 is easy to work with versus 99. That's close. 100 is very close to 99, so we could do 100 minus 1, because 100 minus 1 is the same as 99. So then, let's do this. We don't really have to do any complex math. So 12 times 100 is 1200 minus 12. And this becomes 1188. That is so much more simpler than doing 12 times 99, in my opinion. Let's look at another example. Let's look at a mixed fraction. So we have 3 times 1 1/4. Alright, let's split apart the whole number and the fraction. So let's do 3 times 1 plus 3 times 1/4. 3 times 1 is 3 plus 3 times 1/4. Well, you have 1/4 times 3, that's 3/4. 3/4, so this is 3 3/4. That makes it a little bit simpler to solve than 3 times 1 1/4. We're just breaking it down, making it a little simpler to do the math. Alright, let's do another example, but let's go into mixing letters and numbers now. Alright. So let's say that we have 7 times x minus 40. Okay, so let's break this apart. So we got 7 times x minus 7 times 40. Okay, so then this becomes at 7x minus 280. Not too bad, right? Distributive property makes life simpler. Let's look at another example. We have 3 times x squared plus x minus 1. Alright, let's break this apart, or simplify this. 3 times x squared, that'd be 3 times x squared, plus symbol, 3 times x. Now we got the minus symbol, 3 times 1. Okay, so this is 3x squared plus 3x minus 3. Okay, so we saw some wonderful examples here. Let's talk about some more definitions. Let's look at the definition term. So this is a number, variable, or product, or quotient. Remember, product is when you multiply, quotient is when you divide, of numbers and variables. Okay, now let's talk about like terms. So we're going to use the same term of term, and we're going to talk about like terms. Okay, these contain the same variables with corresponding variables having the same power. Okay, and let's cover one more term, coefficient. Okay, this is a numerical factor. All right, I've thrown 3 new definitions at you, so let's see what this really is. Let's say we have x cubed minus 3x squared plus x squared plus 5 plus 4. Okay? Now, remember when we have a number and it doesn't have a letter next to it, it's the same as having a letter to the 0 power. So like, for example, this would be 5x to the 0 power. Okay? Because the letter to the 0 power is just 1, and 5 times 1 is still 5. So if they have the same power and the same letter, like this one and this one, these would be like terms. So we can combine like terms. And if we have a number in front of the letter, like this 3 over here, what is the number in front of this x cubed? It's actually a 1. Anytime you don't have a number in front of the letter, it's a 1. Same thing here. This will be a 1. Alright, so let's see what this would equal if we combine like terms. So we got x cubed. Alright, so now we have minus 3x squared and we have plus x squared. So that's like minus 3 plus 1, which is minus 2x squared. Good job. And now we have like terms of 5 and 4. So 5 plus 4 is 9. So I broke this down a little quick. The way we could have done this is doing x cubed plus minus 3 plus 1 x squared plus x, let's back up, 5 plus 4 times x to the 0. And we know that this becomes 1, so we just have to sum these and sum these. So then that gives us x cubed minus 2x squared plus 9, using the distributive property. Okay, let's solve a few problems. That sounds fun to me. Alright, so we have a rectangle. This side is B and this side is C. And let's say that the perimeter of rectangle, which we'll define as P, is equal to 2 times B plus C. So you can see how this would use the distributive property of 2 times B plus 2 times C. Okay? And we know that B is equal to 1/5 of P. So the length of B side, which is on two sides here, we have a B here, that is equal to 1/5 of the entire perimeter around the rectangle. So what we're supposed to solve here is we want to know what are B and C. Okay? So here we use the distributive property, but we want to plug in B over here. Okay? So if we say that we have 2 times 1/5 P plus 2C is equal to P. So if we simplify this, 2 times 1/5 is 2/5 P plus 2C is equal to P. Well, we have like terms here. We have a P here and a P here. So we can subtract 2/5 P from each side. Okay, so then that gives us that 2C is equal to 3/5 P. So then we can divide each side by 2, and that gives us that C is equal to 3/10 P. Okay, so there's one bit of information I think I forgot to tell you, and that is that the area is equal to 13.5 meters squared. Okay? 13.5 meters squared. So we know that area is equal to B times C, and that's equal to 13.5 meters squared. So if we know B, what is B? It is 1/5 of P. So that is 1/5 P, and then times C, that's 3/10 P. So that gives us 3/50 P squared. Alright, so now let's change this mixed fraction to an improper fraction, okay? So let's change it to 13 times 2 is 26 plus 1 is 27. 27 over 2 meters squared is equal to 3 over 50 p squared. All right. So then, if we divide both sides by, I don't know what that was doing. I don't know what it's still doing. All right. We'll just divide both sides by 3 over 50. Okay. So that gives us that 1350 over 6 is equal to p squared. So then that gives us that 225 is equal to p squared. Okay, and then we can find out from this if we take the square root of each side, and it just totally got rid of my square root symbol. There we go. Then this tells me that p is equal to 15 when I take the square root of 225. Now, we remember from earlier that b is equal to 1/5 p. So b is equal to 1/5 p. So this is equal to 1/5 times 15, which is equal to, I wrote that wrong, 1/5 times 15. That is equal to 3. Okay, so we also know that we solved up here, we know that c is 3/10 of p. So c equals 3/10 of p. So this is the same as 3/10 times 15, which is equal to 45 over 10, which is equal to 4.5. So now we found b is 3, we found c is 4.5. So what if we just wanted to know the perimeter, which is p? We solved for it also. It was 15. So let's see if this holds true for the distributive property. 15 should be equal to, p is equal to 2 times b plus c, right? So 2 times 3 plus 4.5. Let me try again. 4.5. Okay, so this is 2 times 7.5. 2 times 7.5 is 15. So that matches. All right, let's look at another example. Let's say that sound travels at 1129 feet per second. Okay, through the air on Earth. Okay, so we want to write an equation that represents how many feet sound can travel through the air on Earth. So that's our goal. We want to write an equation that describes this. So we have to choose some variables. Okay? Let's say that d is distance. And let's say that x is seconds. Alright? So the way I write this is the distance is equal to this speed, 1129 feet per second, times x. Alright, let's see if this works now in this next part of the problem. Let's ask, how far can sound travel in 2 seconds when traveling through got extra T there, through the air on Earth. Okay, so using this equation, we're going to say d, which is the distance, is equal to 1129 feet per second times 2 seconds. Alright, so our seconds cancel out. And this is equal to 2,258 feet. Because it's just the 2 times 1129, all in feet. Alright, great job. We will see you next time when we're going to talk about some more properties in math. If you like the channel, please subscribe and click the like button.